So good morning students. Today we are going to study the graphical algebraic method. If you remember, yesterday we studied the graphical method, and graphical algebraic method is almost same with the graphical method. Only one little part is different. So what we are going to do in the first step, find the values of xy for each given constraint. This is the first step that we were studying yesterday. Draw the lines and find the feasible region. This we studied yesterday. Number 3, select all the corners of the region. Now this is the new thing. Point number 4. Up to point number 3, it is same to same like yesterday. Only point number 4 is find the value, or you can say make a table between the corner values. Generally we call them vertex. Corner values and the value of z. Clear? And then point number 5, find the optimal solution. What is optimal solution? Optimal means if they ask you maximum value, so you need to find the maximum value, or if they ask you minimum value, you need to find the minimum value. This is the optimal solution. So to find the optimal solution, we need to make a table here between the vertex values, means corner values, and the values of z. And then we will search if the value of z having the minimum or maximum. Clear? It can be understood with the help of one example. So we will discuss a very good example that may be helpful for you. It is maximum z equals to 2x plus 2y subjected to, it is x plus y less than equal to 6, x4 y x5 y5, x5 and y4, and non-negative restrictions, x is greater than equal to 0, y is greater than equal to 0. So the question is same to same. There is no change in question. This is the objective function. These three are the constraints, and this is the non-negative restrictions. The question is same. There is no change in question. Now, step number 1, solve equation 1. Find the value of x and y. Solve equation 1. If you will solve equation 1, what is the value? The equation is x plus y less than equal to 6. So what we were doing? Changing it into equal. X plus y equal to 6. And after write in equal form, find the value of x and y. Here the value of y 0, here the value of x is 0. Now please tell me, if y 0, what is the value of x? 6. And if x 0, what is the value of y?
6.
It is 6. Very good. Okay, so we solve this equation. The value of x is 6, y is 6. Okay, now equation 2, there is no need to solve. They have written x less than equal to 5. And equation 3 also no need to solve. They have written y less than equal to 4. Okay, so these values have been given 6, 6, 5 and 4. Now we need to draw this on the graph. Okay, so let us select the equation. This is this one, and let us take this is x-axis, and then this is y-axis. This is x and this is y. Now mark the points. It is 1, 2, 3, 4, 5 and 6. It is 1, 2, 3, 4, 5 and 6. This is clear. Now if you will see what are the values, x is 6, y is 6, 3, 3, 6. So here this is 6, here this is 6. Now let us join it with a line. This one and little down here class. This is equation number 1. What is equation number 2? X less than equal to 5. X less than equal to 5. X is equal to 5. This will be the line parallel to y-axis. And bring it here. Yes, x is equal to 5 and less than. Correct? And y less than 4. Y less than 4 means it will be 1, 2, 3, 4. It will be here. Yes, this is clear. And now if you want to let me use submit, this is and move. Okay. Now if you see, this is x equal to 5. This is y equal to 4. And this line is x plus y equal to 6. Now you can see, now little attention. What? Here less than this. Here less than this. Here less than this. Y is less than 4. This side less than means origin side here. Here y is greater than 0 and here x is greater than 0. So where is the shaded portion? If you will find the shaded portion is here. This is the actual required, what we need, x plus y less than 6. Following the condition, it is x less than 5. It is y less than 4. It is x greater than 0. It is y greater than 0. So this is the bounded portion. This is the region. And my dear friends, if you will see, you need to select the corners. What are the corners? This is corner number O. This is corner number A. This is corner number B. This is corner number C. And this is corner number D. Now you need to write the coordinates. This is center. Coordinates are 0, 0. Here the coordinates of A 1, 2, 3, 4, 5. This A point is on x-axis. So it is 5, 0. Here this point D on y-axis 1, 2, 3, 4. So what is the coordinate? 0, 4. Now you need to find the value of B and value at C. Coordinate. Clear? If you will see B, the first value is x, and on this line x is equal to 5. So it is 5. Now if you want to find the value of y here, this is the intersection point of this line and this line. It is the intersection of two lines, x is equal to 5 and x plus y is equal to 6. So it is 5 plus y equal to 6. You need to find the value of y. You need to find the value of y. Why we put 5 here? Because x is equal to 5. So y is equal to 6 minus 5. The value of y is 1. So this coordinate becomes 5, 1. Now if you want to see the coordinate here, the value of x is not known, but the value of y is given. So the value of y is 4. The value of y is 4. Value of y is known to us. So if value of y is 4, so what will do? X plus 4 is equal to 6. Because it is the intersection of this line and this line. This line is y is equal to 4. So we can find the value of x with the help of other equation. So x is equal to 6 minus 4 and x is equal to 2. This is. So here the value is 2. So dear friends, what is the step number 1? Step number 1 is to solve the equation for x and y. Find the value of x and y. Point number 2, draw this region, draw this region. After drawing this region, find the corners O, A, B, C and D. These are the 5 corners. So if you remember, in the graphical method, we were drawing iso cost line and iso profit line. These lines we were drawing. But here, my friends, we are not drawing any line. What we are going to do here? We are going to make a table here. Set of values. What type of table? It will be, it is very simple. It is not difficult. Here it is the vertex. What is the vertex? And here it is the Z value. And how many vertices are there? O, A, B, C and D. These are the 5 vertices. What are the coordinates? Let us see. 0, 0, 5, 0, 5, 1. It is 0, 0. It is 5, 0. It is 5, 1. And what is C? C is 2, 4 and 0, 4. So these are the corners. These are the vertices. You can say corners. These are the vertices. Okay. Now, what is Z? Let us see. Z is 2x plus 2y. This is Z. So Z is equal to 2x plus 2y. So it is 2 into 0 plus 2 into 0. So the answer is 0. 2 into 5 plus 2 into 0. 2 into 5 is 10 plus 0. 10. Now 2 into 5 plus 2 into 1. It is 2 into 5, 10 plus 2, 12. Now 2 into 2 plus 2 into 4. 2 into 2 is 4 plus 2 into 4 is 8. 4 plus 8 is 12. Clear? And 2 into 0 plus 2 into 4. 0 plus 8. The answer is 8. So dear friends, these are the values of Z. Clear? And please note down here, this, if you want to see, this is the minimum value. Minimum 0. But maximum value exists at 2 point. But we are not concerned whether the maximum value exists at 2 points or 3 points. No. So if you want to calculate what is the minimum value of Z, it is 0. What is the maximum value of Z? It is 12. So dear friends, this is the graphical algebraic method. Graphical algebraic method, you can see this is step number 1. You need to find the value of x and y class. Then step number 2, you draw this region and then mark it. What is this? Feasible region. This is. So here we are not going to write ISO profit line or ISO cost line. We are not going to make any line. This is for maximum and this is for minimum. So we are not going to make any ISO profit or ISO cost line. Here what we need to do, here what is the difference between the previous method and this method? We need to calculate the value of corner 1, corner 2, corner 3, corner 4 and corner 5. You need to find the value of Z at all the 4 corners. Clear? And how you will calculate? You will calculate like this table. Clear? So you can see from this they have solved like this is the question. They have given this question, draw the feasible region, this is the feasible region and then make the table. Clear? Then search minimum. Minimum is 14. This is the minimum value and maximum is 51. So minimum is at 0.2 and maximum is at 6.3. This is called graphical algebraic method. So in this method we need to make this table. This is extra in this question. Clear? Now we will study some properties. What is the property number 1? Property number 1. If the value of Z exists same at 2 points. If the value of Z same at 2 points, like you can see 12 and 12. Clear? So the maximum value is same at 2 points. Then there is a property, if the value of Z same at 2 points. Clear? Then the optimal solution. Optimal solution means maximum or minimum will be same on the line joining the 2 points. What does it mean? The meaning of this property is if the value of Z is same at 2 points. If the value of Z is same at 2 points, then the maximum value or minimum value will be same on the line joining the 2 points. That means what? Here if you can see, the value is same at where? 5, 1 and 2, 4, B, C. So value is same here at C point and at B point in these points. So the maximum value 12 will exist on every point of the line joining these 2 points. So this is the line joining these 2 points. So the same value will exist at these at the points on this line, whatever this is the line. And you can see, I will show you this with the help of one what we call it isoprofit line. Clear? What is the function? Let us see the function. Function is 2x plus 2y. If you will take 2x plus 2y is equal to, let us take 4. 2 into 2, 4. Find the value of x. Find the value of z, y. If it is 0, if it is 0. If x is 0, what is the value of x? Please tell me.
No.
Yes. And if x is 0, what is the value of y?
No.
It is 2. So the answer is 2, 2. Now I want to show you isoprofit line. Please see. 2, 2. Now I will join the line. Wait. Yes. This is the line. This is the line 2, 2. Now if I am bringing down, it becomes a isocost line. If you remember yesterday I explained you, if we are bringing this line, downside, clear, then this line will become isocost line. If we are taking it to above, it will become the isoprofit line. So if coming towards origin, it is isocost line. Isocost line. So this is the isocost line. Now draw the another line. You can see. Now if you will take it to maximum side, it is basically not coming. It is like this. Now it is okay. So it is coming to 2. So if you will take it to, so you see there is no corner here. Complete line is coming. Complete line is coming. Understand or not understand? You can see here complete line we are getting. Understand?
Yes, Mr.
So because complete line, there is no corner coming. Here you can see corner is coming, but here no corner is coming. Every point is coming. That's why I am telling you, if there is one corner maximum value is there, then every point here on this line, every point joining these 2 points, every point on this line will give you the optimal solution. Since B and C are giving maximum value of Z, so every point on the line BC will give you optimal solution. Optimal means either maximum or minimum. Optimal solution. So dear friends, this is property number 1. Now we'll move to property number 2. What is property number 2? Property number 2 is if the feasible region is bounded, and you can say and closed, like this one. This is closed and bounded. You can see it is closed here, closed here, closed here, closed here, closed here, fully closed. So if we have a bounded region, or you can say feasible region is bounded and closed, then the LPP will have one maximum solution and one minimum solution. This is, it is always and. You can see yesterday we solved 3 questions. In all the 3 questions there was a maximum value and there was a minimum value, because yesterday we solved all the questions related to the closed and bounded form. Here you can see this is minimum value, and here you can see this line is the maximum value. Why? Because it is closed. You can see it is closed. So we are having a maximum and a minimum value. Now property number 3. If the region is not closed or unbounded, means region not closed or it is unbounded. I will show you. Clear? Then the LPP, linear programming problem, may have one maximum value or one minimum value or no solution. No solution. So dear friends, if the question is closed, like this is closed, clear? You can see this is closed. So this will have a maximum value and a minimum value. You can see, I show you. This is minimum value 14 and this is maximum value. You can see the previous question also. The region is bounded, closed and bounded. So it having a minimum value 0 and it having a maximum value 18. So if region is closed and bounded, definitely maximum and minimum value possible. But by chance, if region is not closed, like you can see this one. If you see this region, then you see it is closed here. It is closed here. You can see lines are here. Clear? But here it is open. Here it is not closed. Here you can see it is open, closed, not closed. So one side it is closed, one side it is open. This is open, not closed. So in such a case, when it is not closed, then it will have either a maximum value or a minimum value, or it may be possible it do not have a solution. Clear? So you can see, if you will find a maximum value in this, because there is no corner here, so no maximum. No maximum. But if you want to calculate minimum, then this is one corner, this is second corner, and this is third corner. You can calculate the values at these corners. What is the function? 4x plus 2y. So 4 plus 8, it is 12 here. Here it is 12. Here 2 1. 4 times 2, 8 plus 2. Here it is 10. And here 4 0. 4 times 4, 16. Clear? So if you will see, the value here is 12, value here is 10, value here is 16. So this is, my dear friends, is the minimum value. This one, this is the minimum value. So out of these points, if you will see, this is the minimum point. But maximum point does not exist here because it is open. It is not closed. This region, this type of regions we called unbounded region. Unbounded. It is not bounded. Bounded means closed, like this one. This is bounded, closed. It is unbounded, not closed. And if it is not closed, then please remember this property. It will have only one. Like in the question, it have a minimum value. It do not have maximum. It do not have no solution. Only one out of these three options will be possible. This is the property number 3. One more question I can show you. This is, you can see, this is also unbounded. This blue is the feasible region, but it is open above. There is no line here. Here there is no line. So it is not closed. Because it is not closed, so this region is not bounded. Unbounded solution is there. And in this case, one corner, second corner, third corner, and fourth corner. These are the 4 corners here. So you need to find the value of these 4 corners, and then you can see no maximum value here because it is open, but minimum value is there. What is the minimum value? It is 22. He has calculated the minimum value at all the 4 corners, and all the 4 corners the value minimum is coming 22. So if problem is not closed, problem is unbounded, then it will have either a maximum value or a minimum value or a no solution. Property number 4. The maximum, the optimal solution. Optimal solution means maximum value oblique minimum value. Lie only on the corners of the feasible region. And please, these 4 properties please prepare, because definitely 1 or 2 will come in true false. Clear? So please prepare these 4 properties. So what is the property number 4? The optimal solution lie only on the corners of the feasible region. This you can understand with the example of this. I told you what? The maximum value or minimum value. You can take any number of points. You take these points and find the value of Z. None of the point will give you maximum or minimum. Minimum, it exists on this corner. Maximum exists on this corner as well as this corner. So what he is saying? He is saying in a linear programming problem, this, the optimal solution, optimal means either it is maximum value or minimum value. It always lies on the corners. This is the property number 4. That's why I am telling you from yesterday onwards that please calculate the value at all the corners. Here this problem have how many corners? 5 corners. So we calculate the value at all 5 corners and then proved this is the minimum value and this is the maximum value. This is property number 4. Now, the last topic we come, there are 3 possibilities. These 3 important things. What is the possibility that linear programming program may be infeasible, feasible and bounded, and unbounded. These are the three options. What are the three options? One is infeasible. What is infeasible? Let us take two things, x plus y less than 1, and here 2x plus y greater than say 4. If you draw these two constraints, these are the two given constraints. If you will draw these two constraints, please listen carefully. X, Y. I am explaining you infeasible solution, infeasible region. Clear? So x plus y, x is 1, y is 1. So this is the line, and less than this. This is less than. Clear? Another is, if you will solve x is equal to 2, y is equal to 4. X is equal to 2 here and y is equal to 4 here. If you will draw this region, then this. Clear? So you can see, because generally non-negative restrictions are x greater than 0, y greater than 0. So if you see above x-axis and right side y-axis, if you see, this is the region. Clear? And this is the region. So my dear friends, these are two different places. There is no common. There is no common region. No common region that satisfy both the constraints. Therefore, it represents infeasible region. It represents infeasible. This is infeasible. We cannot calculate anything. Infeasible. Okay. So one type of solution is infeasible. This is infeasible. Clear? Another is feasible and bounded. This is feasible. You can find the feasible region, and it is bounded. This is second type of possibility. And the third type of possibility is unbounded. Look, this is unbounded solution, unbounded region. This is because it is open here, unbounded. This is open here, unbounded. Clear? So dear friends, there are three possibilities. One possibility is it is infeasible, means we are not getting anything common. Another is feasible and bounded. This is like this one, feasible and bounded. And the third one is it is open above. It is open, you can say. It is unbounded. This region is called unbounded region. So because unbounded, so it have no maximum. It can have minimum because downside it is corners there. So dear friends, this is the end of graphical method. This was the graphical method, and next lecture we will start algebraic method. If you have any problem, please speak.